Hi, I'm Pasan, an iOS instructor at Treehouse, and welcome to the course on Swift enumerations. For this course, I'm going to assume you're familiar with object-oriented programming in Swift and taken all of the prerequisite courses. Over the next few videos, we're going to learn about a new type called enumerations, or as they're more commonly known, enums or enums. An enum is a construct in Swift that allows us to model a finite grouping of data or a group of related types. Enums are common in a few different languages, and in Swift, it traces its history to enums in the C language. But enums in Swift are a lot more flexible, and in fact, they resemble objects and concepts we've already learned quite a bit. Let's jump right in by creating a new playground. We'll name this Enumerations and Optionals, and as always, we'll just leave this set to iOS. Let me get rid of all this and make some room. We've talked about modeling data, and so far we've used both objects and collections to do that. There are certain kinds of data, though, for where these solutions aren't ideally suited. And this is data that is a fixed set of values. Let's look at an example. Let's say we want to model a typical week for something like a calendar app. We can declare an array of strings named week. So we'll say let week equal, and to this array we can add days of the week as strings. So we'll start with Sunday, Monday, Tuesday, and so on. So far so good, right? Based on what we know, an array seems like the best choice here. An object won't work. We won't be creating instances of Monday, for example. We just need a value to indicate what day of the week it is. Now, let's try and use this data in some way. Let's say this calendar app of ours turns off notifications on the weekend so that we can enjoy life. Well, to do that, we need to know whether it's a weekday or a weekend, right? Now, we're going to make this very simple and just focus on my use case, where a weekend is Saturday or Sunday. I know it's different in different countries. Let's write a really simple function. In a more realistic scenario, we would have an object handling all of this functionality, figuring out what type of day it is, but we're going to keep our example lean. So we have this function. We'll call it dayType. And it takes a string named day as a parameter, and then returns a string as well. Inside the body of the function, we'll switch on the argument for day and let the caller of the function know if it's a weekend or a weekday by returning another string. So we'll say switch day. And then in the case of Saturday or Sunday, we want to return weekend. In the case of everything else, Monday, let's say Tuesday, Wednesday, Thursday, and Friday, will return weekday. Now we need a default case, so let's add that. If it's anything else other than these cases, we'll return this isn't a valid day in the Western calendar. Let's indent these nicely. Okay, this path we're taking, though, is fraught with peril. One thing you will learn with experience is that using strings as values, in cases like these, as a value to determine the next step in our process is a terrible decision. You'll see why in just a second. So we have our first function. Let's write another. Again, this will be a trivial function that doesn't really do much other than illustrate our example. We'll call this second function isNotificationMuted. It takes a parameter named day, and again, notice with both of these, we're giving it sensible external names so that it reads better. So it takes a parameter named day of type string, and it returns a Boolean value indicating whether the notifications were muted or not. So this is simple. We'll say if day equal weekend,
then we'll return true. Otherwise, we'll return false. Okay, so we have this second function now. We can do something like this. We'll say let result, and to this we'll assign the value of calling that first function. So day type for string. And now we have an array of strings up here that kind of pertain to a week. So we'll just use subscript notation and get a random value out. Okay, so we'll see that the result is weekday. Now, let's say let is muted, and to this, we'll assign the value of calling is notification muted. And on what day do we want to check? Well, we'll pass through the result. This seems to work, right? But if I decide that instead of using the array here, I want to pass the string into the function directly, we could do something like this. We'll get rid of that, and I'll type Monday. And it's still a weekday, so is muted is still false. Now, the problem is I'm pretty bad at typing. And instead of Monday, I could type Moonday, for example. Whoops, so now it is Monday, but my code thinks this isn't a valid day. Now, is muted still returns the right value because of the way our logic is constructed, but you'll see that the string we're getting is not an actual day type. So another mistake I could make is instead of spelling Monday, I could say SAR today instead of Saturday. Using strings like this is risky because a simple spelling error, a typo, leads to mistakes all over the place. Mistakes that are often quite hard to catch. What if instead of mistakenly typing the days over here, I had typed it out incorrectly in the actual array? Now, everywhere I'm using the array, there's going to be errors. And the worst part is, even though Swift is a strict language and we expect the compiler to help us out, in this case, because we're using strings and it can't figure out whether this is a right day or not, the compiler can't help us. So how can we solve this? On to the next video.